Multiplying polynomials, part 2. Okay. So in this video I'm going to show you the third method, which is the rectangle model, also known as the box method. We went over the distributive property method, the FOIL method, and now the box method. Now this one is really nice because you can see how your numbers are organized in a box, in squares actually. And this is how you're going to do it. So we have two binomials because there's two terms in both of them, and they're getting multiplied. So this is similar to the Punnett square method that you're taught in biology. So to organize this, I'm going to use this first term here, x, that is a positive 5, and then I'm going to use this second term, the second binomial here. Okay, so what we're doing is we're finding the area of a square. So here's a square, or a rectangle I should say. If this is 3 and this is 2, how do you find the area? Well, you would multiply the 2, the area would be 6. So that's what we're doing here. We're finding the area of each individual rectangle. Okay. To do that, we're going to pay attention to the dimensions that are to the left and up above. So we're going to start with the first rectangle. Here we have x times x. Properties of exponents, x squared. Okay. Next I'm going to use this rectangle. So remember, the dimensions are x is this length times 5. Okay. So this times this gives us a positive 5x. Okay. Next rectangle, this one here. I'm going to use the dimension that is far to the left, which is x, and the one that is right above, which is 4. So x times 4 gives us a positive 4x. And lastly, for this rectangle, I'm going to use the dimensions for this number and this number. So that is 5 times 4. 5 times 4 gives us a positive 20. So I'm going to put it right here. Okay. What we're going to do next is I'm going to write this out in standard form, which is descending order. So I'm starting with the x squared. Then, as you can see, we have two x's. It doesn't matter which one you put first. So I'll do this. At the end is our constant. Okay. Combine your like terms, which here we happen to have like terms, the x's. After doing that, we get our final answer, which is x squared plus 9x plus 20. And as you can see, the 9x comes from combining these two numbers that are here diagonally, 5 plus 4. Okay, so let's try another one. Again, box method. First thing you want to do is organize. First binomial goes here. Second binomial goes here. Okay. To fill in each individual rectangle, remember we're finding the area. So, the area of this one is 2y times y. That gives us 2y squared, because there's two y's getting multiplied. The next one, I'm going to do this one instead. So here we have 2y times negative 3, which gives us a negative 6y. Okay, and I'm going to move over to this rectangle. So we have 6 times y that is a positive 6y. And for the last rectangle, we have this number right above and this number to the left. So 6 times negative 3, negative 18. Okay. So again, I'm going to copy these numbers in standard form, which is descending order. So we'll start with the highest power, then the next one, and at the end is our constant. So, combining our like terms, we get that these two are the same. They have something in common. So our final answer is 2y squared. But negative 6y with a positive 6y, well, these two numbers give us 0. So I don't need to write that 0. I'm just going to bring down the minus 18. And that is our final answer. Okay. Next example. I don't have my rectangle here, or my box one, so I'm going to go ahead and do one. Okay, I'm going to set up my dimensions. First binomial, first term goes here, second term goes here. Second binomial, first term goes here, second term goes here. All right, so here we have for this square, or for this rectangle I should say, negative 4x times 3x. Negative 4 times 3 is negative 12. X times x, x squared. Okay. Next rectangle. Here we have 1 times 3x. That gives us a positive 3x. Okay. This rectangle here. We have negative 4x times 9. That gives us a negative 36x. And lastly, we have positive 1 times positive 9. That gives us a positive 9. Okay. So, I'm going to rewrite this, the results I got, in standard form. And I'm going to combine my two like terms, which is negative 3x, negative 36x, and positive 3x. And as you can see, it's the two numbers that we have diagonally. Okay, so simplifying, this gives us negative 12x squared minus 33x plus 9. And that is our final answer. So not bad for the box method. It's pretty neat. You can organize everything, understand how to multiply things. But what happens when you have a binomial times a trinomial? So now the problems are getting a little bigger. Okay. Now, when it comes to bigger problems like this, there's only two ways you can do it. Either use the distributive property or the box method. Okay. So let's go ahead and do the distributive property. Distributive property says ignore this term. Okay. So I'm going to copy what I have. I'm going to multiply 6x times this huge trinomial. Then it says, okay, now let's ignore the first term and multiply the second term times the whole trinomial. So here it is. That is a plus 5 times all of this. So we're going to distribute. 6x times 2x squared. 6 times 2 is 12. X times x squared at the powers, x to the power of 3. Next one. 6x times negative 3x. 6 times negative 3 is negative 18. X times x is x squared. And the last one. 6x times negative 5. That is a negative 30 with the x. Okay, so next one here. 5 times 2x squared. 5 times 2 is 10, x squared. 5 times negative 3x, that is negative 15x. 5 times negative 5, negative 25. So that is a long polynomial. What we're going to do next is commutative property. I'm going to rewrite them in descending order, standard form. So I need the highest power to be my leading term, x to the power of 3. Then I need the terms of x to the power of 2. So there you go. Then I need the terms with x to the power of 1. There you go. And finally the constant. So I'm going to go ahead and assume that this is already the associative property, which means combine them. So this is 12x to the power of 3. Negative 18 plus 10 is negative 8x squared. We have another group here, negative 30x minus 15x. That is a negative 45x. And bring down the constant, negative 25. This is our final answer after we multiply those two polynomials. So it ends up being a pretty long polynomial. Let's try another one. Okay. Now you might be thinking, well, why don't we just do the FOIL method? Okay. Remember FOIL, in 4 steps you get your answer. So first times first, first times last, inner, and then last times last. So if we do the FOIL method, what's happening to this number? It's not getting multiplied. It has to get multiplied. So therefore, the FOIL method does not work here. So instead, we use the distributive property. We're going to ignore this term, and then we're going to rewrite 3x is getting multiplied into all of this here. Okay. Bring back this here, the plus 2. Now let's ignore the first term. Now we have a positive 2 multiplying into all of that trinomial. So we're going to go ahead and distribute. 3x times 2x squared. 3 times 2 is 6. X squared times x, x to the power of 3. 3x times negative 4x. 3 times negative 4 is negative 12. X times x, x squared. The next one. 3x times 5, that is a positive 15. Moving on to the next. 2 times 2x squared, that is a 4x squared. 2 times negative 4x, negative 8x. 2 times 5, positive 10. Alright, pretty long. The next thing is commutative property. Move things around so we have the like terms next to each other. Starting off with the highest power, power of 3, x to the power of 2, x to the power of 1. Oh, and I forgot my x right here. Sorry about that. So that is a positive 15 minus 8x, and then the plus 10. Okay. These two are groups. These two are groups. So I'm going to put them together. This is 6x to the power of 3, negative 12x squared plus 4x squared. That is a negative 8 with the x squared. 15x minus 8x, that is a positive 7x, and bring down the plus 10. This is our final answer. Pretty long polynomial. Now, distributive property is not the only way that we can solve these. We could also use the box method. It's nice and simple. Okay. So as you can see, in my box method, before we only had 4 rectangles to worry about. Well, now we need 6. Why? Because we have a binomial times a trinomial. Okay. So let's see. I'm going to organize these numbers and put them where they belong. The first polynomial goes here. The second one goes here. I'm going to multiply everything, finding the area. Okay. First, I'm going to multiply these two. And that gives me a positive 12x to the power of 3. Next, I'm going to do that area. So 5 times 2x squared, positive 10x squared. Next one, 6x times negative 3x, negative 18x squared. Okay. 5 times negative 3x, that is a negative 15x. 6x times negative 5, negative 30x. And lastly, 5 times negative 5, negative 25. Okay. Now, if you ever doubt if you did this right or wrong, look at the diagonals. They should have something in common, the same variable. Okay. So, I'm going to go ahead and write this out in standard form, so descending order. And then minus 15x, minus 30x, doesn't matter which one comes first. At the end, minus 25. Okay. So these two are like terms. These two are like terms. Combining everything, and this is the final answer. Pretty long polynomial. Okay. Let's try another one. So again, we have a binomial times a trinomial. So the box method works really nice. We're going to find the area. So I'm going to be filling these in. This times that, positive 21, x squared. This times that, negative 24x. This term times that term, negative 10x squared. This term times that term, negative 35. And lastly, this term with that term, positive 40. So, oh, I made a mistake. This here should have been a power of 3. I went too fast. That should have been a power of 3. Okay, so what we're going to do next is I'm going to write this out, starting with the highest degree, which is the power of 3. Then I'm going to combine the diagonals. That is negative 10x squared plus 21. That gives us a positive 11x squared. Next, I'm going to combine the next diagonal, because these two are my like terms. So that is negative 35x minus 24x. Add the two numbers, keep the sign. So the only ones that didn't have other like terms were the first term and the last term. Okay, so this would be our final answer.